cementitious materials. These materials are called as the materials which can supplement the cementitious properties. These are the byproducts, which is used with in conjunction with the cement and which contributes towards the binding ability of the cement through pozzolanic reaction. So it means we have cement already there. So we add these materials into the cement and they supplement it. They give the enhanced characteristics of the cementitious properties of the cement. So it means these products, these materials, they are going to supplement the binding ability of the cement. They contribute to the properties of the concrete by hydraulic or pozzolanic reaction. They are there within the cement and they will contribute towards the binding ability of the cement. Now, what are these supplementary cementitious materials? There are a lot of actually, you can say, but few of them are very commonly used within the cement industry. Number one is fly ash, silica fume, slag, natural pozzolans. There are other as well. One is metakaolin, that is called as calcinide clay. Slag is there, or calcinide shales are there. And sometimes you use ashes as well. These ashes can also be used as supplementary cementitious material. So you name them as just like over here, cash. These ashes can also be used as supplementary cementitious material until unless they give the binding ability, they give the characteristics of binding to the cement. So what is pozzolan? Pozzolan is a siliceous material or aluminous material, which is, you can say, finely grinded. And once the cement comes or the moisture comes, it chemically reacts with the calcium hydroxide, and that is actually there. If you go back, and we just a while ago, before 10-20 minutes, we discussed that the major constituent which is in the cement that is causing the problem, there was unsoluble calcium hydroxide. Student, if you remember, are you there?
Yes,
Yes,
sir.
sir.
Yes, sir.
So अभी हमने बात की कि is actually calcite. Calcium silicate hydrate is a stable compound. However, calcium hydroxide is a unstable compound. Isn't it? This is what we discussed a while ago. थोड़ी देर पहले हमने इस पे डिस्कशन की है.
Yes, sir.
So this calcium hydroxide is already available within the cement. It can be reacted with these siliceous materials and they make a secondary calcium silicate hydrate. ये secondary silicate calcium silicate hydrate बनाते हैं. That is even more stable, that reacts and that gets stabilized. This is the reason के supplementary cementitious materials जो हैं वो durability को chemistry wise control करते हैं. If you remember last time, maybe 2 weeks back, once we discussed cement, what was the average particle size of the cement which we were discussing? Can anybody tell?
So 50 microns? 10
Uh,
to
10, 10 to 50 microns. Okay. So, whereas talking about these natural pozzolans, they have sizes above than this or below than this as well. So they are in both categories. Most of them are below than 10 micron or 15 micron. So once we go for the binding ability of the cementitious material, there are two things. One is physical characteristic and second one is chemical. So talking about the chemical reaction, this calcium hydroxide, it is being, you can say, accompanied by the siliceous compound that is available within the cementitious materials, and it react and it make a secondary supplementary cementitious, secondary calcium silicate hydrate. However, talking about their physical interaction. So it means our supplementary cementitious materials, they will react more efficiently if they are finely grounded. They are very fine. They are finer than the cement. So we can have more, you can say, efficiency of the supplementary cementitious materials. So we can define them the pozzolans. What are the natural pozzolans? Natural pozzolans are the pozzolans material naturally available, such like clays or which is calcinide or which is occurred due to the evolution of the fire, something like eruption of volcanoes. So we have metakaolin, and metakaolin is actually kaolin being calcinide at a higher temperature of more than 1200 degrees Celsius. So once this kaolin clay is being calcinide at higher temperature, we call it as metakaolin and then finely grinded. Rice husk is there, as I told you. This rice husk ash is also used as natural pozzolans. So these can be used as supplementary cementitious materials. So how they react? They react with these CH. As I told you in the last slide in the cement discussion, the CSH is a binder responsible for strength. The CH does not have an important contribution to the strength and certain problem with the durability. So remember, students, whenever you talk about the durability, you have studied it in detail, I think, with Dr. Safir already. So this CH is actually the element which is responsible for any kind of durability related issues. So we can have this solved if we can stabilize the CH. By any mean, if we can stabilize the CH, we can have reduced durability issues. So what we do, we react with these siliceous properties available within this pozzolans. These are called as amorphous silicas, reactive amorphous silicas. So once they react with the CH, they make calcium silicate hydrate. This is more refined, this is dense, and this will make more mechanical strength actually. This is the reason once we add fly ash, silica fume, slag into the cement, and we get more strength characteristics, more durability related issues. We have better porosity, we have better permeability. Okay, talking about these two words, porosity and permeability, can anybody tell the difference between these two terms? Students, can you tell what is the difference between porosity and permeability?
सर porosity number of pores define करते हैं इसमें, और जो
जी
permeability होती है how pores are connected.
बिल्कुल ठीक. So if the pores are interconnected, that is called as permeability. So it does not necessarily means कि अगर किसी system of cement में और concrete में आपके पास porosity higher है, तो उसकी permeability भी higher हो. ये जरूरी नहीं है. Because porosity, permeability does not mean that more pores. Permeability comes like that these pores are interconnected or not. Clear? So once we have this supplementary cementitious materials, they can fill the porosity, they can reduce the pores, and they can also react with unstable CH, which is actually causing the most of the durability related problems. So अगर आपसे कोई पूछे कि जी why this pozzolans are or the supplementary cementitious materials are, how they are mechanism wise, how they are increasing the durability, so you can give this reaction that CH will react with the amorphous silica and it will give you the secondary calcium silicate hydrate. This is one effect actually, pozzolanic reaction. So if you see over here, they make CSH and CH. Then this CH will react with the pozzolan in presence of water. It will again make the calcium silicate hydrate. So this first reaction is reaction of what? Cement. The second reaction is reaction of supplementary cementitious materials. So are you okay with this, students?
सर अगर ये मटेरियल ज्यादा फाइन है सीमेंट से तो ये सीमेंट से पहले रिएक्ट नहीं कर लेंगे?
जी जी। नो, एक्चुअली व्हेन सीमेंट रिएक्ट करेगा, चूंकि इनकी अपनी कैपेसिटी ऑफ बाइंडिंग एबिलिटी नहीं है, दे आर नॉट, यू कैन से, अगर ये वैसे बाइंडिंग एबिलिटी हो तो फिर सीमेंट की तो जरूरत ही नहीं है, इन्हें खुद ही पानी में ऐड करें तो यू कैन यूज एज द बाइंडर। दे आर इनर्ट इटसेल्फ, ये खुद इनर्ट है, खुद नहीं ये रिएक्ट करते। दे नीड अ chemical which can activate them, and that activation comes through the cement, actually that comes through the CH. Are we clear?
जी सर।
मतलब आप इसको इस तरह से समझिए कि अगर हम फ्लाई ऐश में पानी डाल दें तो फ्लाई ऐश को बाइंड हो जाना चाहिए, जिस फिलॉसफी पे आप बात कर रहे हैं, isn't it?
जी सर।
But it does not happen actually. So then they need an activator. So once we add that activator can be cement, that activator can be alkalinities, that alkaline, those can be sodium silicate, those can be sodium hydroxide. So those are there in the market as well. लेकिन इन सप्लीमेंट्री सीमेंटिशियस मटेरियल और पोजोलान्स को एक्टिवेट करने के लिए कोई ना कोई एक्टिवेटर चाहिए। So what we do over here, we add cement, we add their partial amount into the cement as a replacement, and then we see that how much efficiently we can use them into the cement. So this is the philosophy behind it actually. Are we clear, ji? This is the reason we call them as supplementary cementitious material. So they supplement the cementitious properties actually. Are you there, students? प्लीज जवाब दिया करें, फिर मुझे याद पता लगे आप हैं।
यस सर।
Otherwise, I am think I'm talking along. Okay, the first effect was chemistry. This is chemical effect. Now we talk about the physical one. Physical effect is actually filler one. If we see that these are the cement particles, so we have ultrafine powder. What it will do, this will fill in the gaps within the cement particles. What are the two major causes which can cause the durability related issues? Can anybody tell? ये तो आपने पढ़ा होगा। Can anybody tell? Anyone who can tell there what are the major causes, what are the problems those are causing the durability related issues? बता सकते हैं जी कोई कि सीमेंट या कंक्रीट में कौन सी ऐसी इश्यूज हैं, कौन सी ऐसी कैरेक्टरिस्टिक्स हैं जिनकी वजह से ड्यूरेबिलिटी प्रॉब्लम आती है? आसान लफ्जों में अगर पूछे। आर यू देयर स्टूडेंट्स?
सर सल्फेट पैक है, कोरोजन है
जी,
फ्रीज का साइकिल्स हैं।
ये तो हैं जो ड्यूरेबिलिटी के इश्यूज हैं। मैं ये पूछ रहा हूँ ये किस वजह से आते हैं, कौन सी ऐसी रीजन है जो कंक्रीट में हो तो उस वजह से ये ड्यूरेबिलिटी इशू आ जाते हैं? क्रैक्स की वजह से आ जाते हैं। और
वाइड्स अगर कम वाइड नहीं कमी को वाइड्स
वाइड जो
सर सल्फेट अटैक, क्लोराइड अटैक।
क्लोराइड अटैक, सल्फेट अटैक, व्हाट एल्स?
कार्बोनेशन।
रिएक्टर सिलिका,
जी जी,
रिएक्टर सिलिका अगर हो,
रिएक्टिव सिलिका हो।
पार्टिकल साइज के ऊपर भी सर डिपेंड करता है। अगर
पार्टिकल साइज पे भी डिपेंड करता है। जी जी, एनीवन एल्स? अभी अगर मैं सारी को समराइज करूं तो दो चीजें आपने बताई हैं. Two things you have told actually. One is due to chemistry or chemical attack. Either वो reactive silica है, either वो chloride है, either वो carbonation है. So one is chemical attack, and other one you told that is called as porosity or voids, isn't it?
यस सर,
ऐसे ही है जी.
यस सर, ऐसे ही है.
तो दो मेजर रीजन है जो ड्यूरेबिलिटी को प्रॉब्लम आ सकते हैं किसी भी कंक्रीट में. वन इज देयर कैन बी porosity or voids, and second can be due to the chemical attack. If either of these things can be there, there will be a durability issue within the concrete. ऐसे ही है जी.
यस सर.
And now if we can solve these two, we can reduce the chances of durability related problems. अगर हम इन दोनों को कम कर दें, शायद आपने सुना होगा डॉक्टर सफीर से, we normally say once, if you want to increase and enhance the durability, you need to reduce the porosity, you need to reduce the voids. कि आप जितनी porosity reduce कर दें उतना आपके पास durability improve हो जाएगी. ऐसे ही है.
यस सर.
So now talking about the enhancing the durability, so if we can enhance the porosity at micro or nano level, that cement particles are interlinked, their voids are there. So these voids can be filled with the ultrafine fillers. This is one physical characteristic. कि हम physically voids को fill कर दें, तो हमारे पास voids नहीं होंगे, porosity reduce हो जाएगी, तो we can enhance the characteristics of the concrete. The first one which we discussed actually, effect one, this is regarding the chemical. So this CH is actually problematic. जैसे किसी क्लास में एक अनस्टेबल स्टूडेंट आ जाए जी, जो स्टूडेंट पूरी क्लास को तंग कर रहा हो, तो टीचर क्या करता है, या उसे क्लास से बाहर निकाल देता है जी. ऐसे ही है, या उसे किसी ऐसी जगह बिठा देगा जहां पे वो आराम से बैठा रहे. आर वी क्लियर?
यस सर.
चलिए मैं इसको एक थोड़ा लाइटर नोट पे एग्जांपल देता हूँ जी. जैसे घरों में एक बच्चा जो है बहुत शैतान हो जाए, घर वाले उसकी शादी कर देते हैं. This is what they do. They
नहीं सर,
bring a
ये true
person
नहीं
in
है.
his life. They bring a person in his life so that he can be a stabilized one. So this CH is unstable. This amorphous silica will stabilize it. This is chemistry wise. Now physically what we are doing, we are reducing the porosity. These pores are being reduced. So these two effects are actually, those are responsible for enhancing the characteristics of concrete or cement by addition of supplementary cementitious materials. Are you there, students? ये दो चीजें समझ आइए, ये बहुत इंपॉर्टेंट है. These are the, you can say, body of any chemistry, cement chemistry. अगर आपको ये दो समझ आ जाती हैं तो आप किसी भी चीज पे डिस्कशन कर सकते हैं, ड्यूरेबिलिटी पे, SCM पे, any effect you can talk with these two terms. अगर ये समझ नहीं आते तो बाकी आप जितना लगाया हुआ वो रट्टा ही है आपका, याद रखिएगा. और क्लियर जी?
यस सर.
So now going to the next, we will try to discuss these supplementary cementitious materials one by one. These, what are these? These are normally, all materials are byproduct. Number one is silica fume. So this silica fume is a very fine non-crystalline silica. This is produced in the electric arc furnace. They are a byproduct actually of silicon industry, where these chips are there. So this is also known as condensed silica fume or microsilica. इसे ये भी कहा जाता है जी. कंडेंस सिलिका भी कहा जाता है और माइक्रो सिलिका भी कहा जाता है. The most, this is more, the other names are condensed silica, micro silica, micropores, silica dust, volatile silica as well. So this is a byproduct. This is a powder produced actually. So it can also come in the water-based slurry as well. This is densified, or you can prepare through it as a blended silica fume cement as well. So this blended silica fume is normally being produced where the silica fume is abundantly available. In Pakistan, silica fume is not abundantly available because we don't have silicon industry over here. So in China maybe, or in the countries where there is a silica industry, we can have these blended silica fume over there. And one more term, you can say type of silica fume, that is pelletiles. This is pellets, actually not dust. So you need to again make it dust to use it actually. So this is in size of 10 to 25 millimeter. So we cannot use directly in form of powder into the concrete. So this silica fume is extremely fine. It is dusty. The normal particle size of the silica fume is, these are in two colors, very gray, dark gray or light gray color. So the grain size is normally lesser than 1 micron or 0.1 micron actually, if you go precisely. So if you go to the ACI 234R report, so you can go up to 15% replacement of cement. So if you have 100% of cement in a concrete, you can reduce it up to 15% with the silica fume. And the most important thing is that with each grain of Portland cement, you see about 2 million particles of silica fume will be there. So this is the fineness of the cement, fineness of the silica fume. That if you have each grain of silica fume, a particle of cement, so over there you have about how many? 2 million particles of the silica fume. So this is the fineness of silica fume. So very fine. So once it is very fine, you will get both effects over there. One effect is filler effect, whereas the other effect is chemical effect. So this chemical effect will enhance the CSH, whereas fineness will reduce the porosity. So in both ways, this silica fume will, you can say, complement to the concrete properties. Are we there, students? You got it or not? जी बेटा जी, इस बात की समझ आई है कि नहीं?
Yes, sir.
So if you see that, it is very fine. It is finer in the sense that one particle is about 2 millionth particle of the cement. So it means the fineness is so much that our one particle can undergo and one particle can accommodate a number of particles of silica fume, which means it will penetrate into the micropores and it will fill the microporosity. It will physically pack the material, and secondly, it will chemically stabilize the CH. So its particle size is less than 1 micron. Its bulk density is between, you can say, 1300 to 1400. Specific gravity is 2.2. So surface area, if you see the surface area, it is 13,000 to 30,000 meters square per kilogram. However, talking about cement, it is about 300 to 700. So this is a lot of surface area is there for the silica fume particles. So you can see over here comparison of this particle size and silica content. So it is written over here, silica fume have a silica content of 85 to 97%. So however, in fly ash, it is 35 to 48%. In cement, it is 20 to 25%. So this silica fume, once we talk about the silica fume, its standard is also there. I think it's 1295 ASTMC 1295 or 1495. I don't remember exactly. It states that the silica fume, the silica content should be greater than 90%. Its surface area is greater than the cement. You see about 100 times more than that. Then pozzolanic activity is about 120 to 200% with the cement. It's 85 to 110% of this cement actually. Then with the lime as well, it is more pozzolanic as with respect to the fly ash. So if you see this graph is telling you that how much, as you are increasing the silica fume content, what is happening actually? Your calcium hydroxide content is being reduced. So starting from 30%, it has gone up to 1 to 2%. So it means if your calcium hydroxide amount is being reduced, so it means your CH is being to make more CSH. So chemically, your CH is being stabilized with silica fume. So over here, physically, over here, the graph is showing chemically. So these two parameters are there to define any concrete. Are we clear, ji?
Yes, sir.
बेटा किसी भी कंक्रीट के लिए remember, whenever you talk about any concrete, there are two parameters. One parameter is there that it should be physically well packed, and the second parameter is there that it should be chemically well binded. So if these two are well organized, well planned, well executed, your concrete is one of the best concretes. So if you see over here, if we have 0% silica fume content, our strength is lesser. So as we are increasing the percentage replacement to 15%, our strength of concrete has increased from 40 megapascal to about 60 to 65 megapascals. Which means we have increased about 50% in strength. So your durability improvement is also there. Why durability improvement is there? Can anybody tell? Now after this discussion, क्यों ड्यूरेबिलिटी इंप्रूवमेंट आई है सिलिका फ्यूम की वजह से? कोई बताएगा जी?
मतलब जो पैकिंग है वो इम्प्रूव हो जाती है और जो पोर्स हैं वो रिड्यूस हो जाते हैं, तो ऑटोमेटिकली जो परमेबिलिटी है वो कम हो जाएगी और इंग्रेस कम होगी तो ड्यूरेबिलिटी इम्प्रूव हो जाएगी.
क्रैकिंग रिड्यूस हो जाएगी, पोर्स कम हो जाएंगे. एनीवन एल्स?
सर फिजिकली एज वो फिलर भी करेगा, एक्ट करेगा और केमिकली भी जो है बाइंडिंग होगी.
ठीक है. एनीवन एल्स?
सर जो CSH कंपोनेंट्स हैं वो भी यूटिलाइज हो जाते हैं, ज़्यादा रिएक्शन होता है तो फिर वो कंज्यूम हो जाते हैं.
I repeat again, there are two things. One is physical, another one is chemical. Physical means there are micropores within the cement. Whenever cement to cement particles are connected, there are voids. जब सीमेंट का पार्टिकल सीमेंट के पार्टिकल के साथ मिलता है जी, तो स्टिल देयर आर voids actually at micro or nano level. Those should be filled so that the pores should be minimum. So talking about chemically, talking about there is unstable CH available within the cement. So this unstable CH should be stabilized with the silica. So this silica will come through the silica fume. So this is the reason that both this durability issue will be solved, actually enhanced. So you will have reduced porosity, you have reduced diffusion of chloride or any kind of corrosion or cracking due to any kind of drying shrinkage. Why? Because the porosity is being reduced to drastically minimum level. Are we clear, ji? ये reason है. Then this test is there that is called as RCPT test, which is called as rapid chlorine ion permeability test, ASTM C1202. इस पे लिखा नहीं हुआ, इसको permeability लिखा हुआ है, लेकिन ये permeability नहीं है. This is called as rapid RCPT ion, that is called as RCPT, rapid chlorine ion permeability test, where we flow the current from one side to the other side through the concrete, and we see that how much is the porosity within the system that allows the current to flow from one part to another part. This ASTM C1202 tells us that as much lesser charge is allowed, it means there is less porosity. So if you see as much more content of silica fume is there, the strength is higher and charge is lesser. That's why RCP values reduced and higher the value of silica fume. Are we okay with it? ये टेस्ट है जी क्लोराइड आयन पेनिट्रेशन का, और इसको अगर सही लफ्जों में बात करें तो दिस इज कॉल्ड एज RCPT टेस्ट. RCPT means rapid chloride ion penetrability test, where from one side of this part we add the ion and it goes to the other side through this concrete. ये concrete sample लगा हुआ है इसके दरमियान में. So and then we see how much charge is there. If charge is higher, it means frost is higher and current can flow easily. Strength is reduced. So ये एक advanced test है to check the porosity or durability. I think you may have discussed it with Dr. Safir. Is it or not? बताइएगा जी बेटा जी, आप लोगों से पूछ रहा हूँ अगर आप हैं वहां पे. Are you there, guys? Can you listen to me?
Yes, sir.
Yes, sir.
Okay. Then silica fume shotcrete. So this silica fume shotcrete is actually shotcrete you see normally internal lining, internaling, or in the structures which are normally exposed, where we need very early strength and early stiffening. So we use silica fume over there. In our case, if we see this Mohammedan Dam, in our the Amir Basha Dam, we are trying to use this silica fume shotcrete. Luckily or unluckily, you see that in Pakistan, we don't have any kind of expertise. We bring it from the China to prepare this shotcrete actually. So this has high binding ability actually. Cohesion is more, it suddenly sticks to the wall and suddenly dry. So that's why we use it actually. Then we have it is written over here that silica fume increases the workability. However, if you see practically very good silica fume, you find out that the silica fume actually reduces the slump. But if you see real silica fume, which is being used by the market, where those are the round particles at SCM, you may see the increased slump. So there are different kinds of, you can say, well, I have worked in my PhD. During my PhD, I have worked on 6 different types of silica fumes. Few of them were complementing the slump, and few were there which were actually drastically reducing the slump. So we cannot say this straight away that every time you see that silica fume is going to, but however, if you see your porosity is being reduced, your mix is consistent, so you may observe that your workability is being enhanced. But for the same water cement ratio, if you want to make it workable, you may need actually the high range water reducers to improve the workability. So are we okay with the silica fume, students? Are we okay with silica fume?
Yes, sir.
Yes, sir.
बेटा ये सिलिका फ्यूम आता है आपका सिलिकॉन इंडस्ट्री से. जब सिलिकॉन इंडस्ट्री में आपके पास डस्ट बनती है सिलिका की, उसको आप यूज करते हैं एज ए बाइंडिंग एबिलिटी, एज ए बाइंडिंग मटेरियल. दैट इज एक्चुअली योर बाइंडिंग मटेरियल. दैट इज वेरी फाइन. डस्ट होती है तो उसे आप एज द नेम स्टेट्स इटसेल्फ, दैट इज सिलिका फ्यूम. तो ये फ्यूम्स है सिलिका का जिसे कलेक्ट किया जाता है. ठीक है, अगर आप इसकी ओरिजिनेशन देखें तो वो भी बाय प्रोडक्ट है. नाउ सेकंड से SCM is that is called as fly ash. So we have fly ash. It is also a byproduct of coal burned power plants. In Pakistan, we have a lot of these nowadays. Sahiwal, Vikki, Thar, Port Qasim. We have a lot of these by CPEC. Or up to, if you go to the different industries, just like Sitara Chemical is there. There are the sugar mills. They are using it, this coal, as a power generation. So you find this fly ash. What is this fly ash? You burn the coal to generate the electricity. Then there is ash generated. One ash is there which is being dumped on the site after burning of coal. And one ash is there which fly with the dust as a dust into the air. दो तरह की ऐश जनरेट होती है जी. एक ऐश वो है जो आपके पास बच जाती है राख की सूरत में, और एक ऐश वो है जो फ्यूम्स के साथ उड़ जाती है. बट द ऐश यू कलेक्ट थ्रू द एयर, दैट इज कॉल्ड एज फ्लाई ऐश, क्योंकि वो उड़ रही है. However, the ash which is being collected as a, you can say, leftover of coal burning, that is called as coal ash. Are we clear? Are we clear, beta ji?
Yes, sir.
Yes, sir.
Yes, sir.
So two kinds of ashes are there. One ash is there which is flying in the air with the fumes, and one ash is there which is left out as a burn of coal. So the flying one is called as fly ash. However, the leftover after the burning of the coal, that is called as coal ash. Clear? Are we clear, ji?
Yes, sir.
It is a pozzolanic material actually which has a spherical particle. This fly ash is always a spherical particle. Spherical means it is more like a balloon structure. This fly ash is most of the times is like a balloon. Whenever you see its SEM, scanning electron microscope image, it is a round balloon-like structure. Clear? Whose size is lesser than 1 millimeter or 1 micron. Actually, you see it's about 8 to 15 micron or maximum 25 micron. There is a standard through which we can classify the fly ash. That is called as ASTM C618. There are two classes of fly ash, class F and class C. Class F is called as low calcium oxide fly ash. This class F is called as low calcium oxide fly ash, or class C is called as high calcium oxide fly ash. This is actually the first one. Class F is being produced by the calcination of bituminous coal, or the second one is by the subbituminous coal, that is called a lignite actually. We normally use class F fly ash. We normally use class F fly ash in our construction industry. So these are the two classes actually which we discussed a while ago. ASTM C618 is the standard for S2M and M295, which classifies these two classes of fly ash, class F fly ash and class C fly ash. This is a microstructure, as I was telling you, that it is more like a spherical balloon-like structure. Once it's rupture, you will see it is a balloon-like structure. Whenever you see other than this image of a fly ash, you cannot see or you cannot say that there is a fly ash. Are we there?
Yes, sir.
कि अगर आप किसी भी SCM को देखें and you find out that their SCM is not like a spherical type, it is a more like irregular shape. So that is something else but not fly ash. If you want to say something as fly ash, it will be like a complete spherical type particles. Now, these are the cement particles. It is a schematical diagram. This filler effect is there. So this is the schematic diagram of the cement particles. And in the cement particles, these fly ash particles are being indulged. These fly ash particles are filling the voids. These voids are being filled with the fly ash particles. So they will reduce the porosity, but not as compared to the silica fume. Silica fume is more finer, that is finer than the fly ash. But however, fly ash is finer than the cement particles. It will improve the filling. Are we there, Ji?
Yes, sir.
So this is the filler effect. Now, if again we see over here, so again this free line will act with the fly ash. There is actually there, and this is a free line. There is, that I told you, is the unstable part within the cement. It will act with the fly ash, which is actually amorphous silica, and it will make a calcium silicate hydrate, which is stable. So through pozzolanic activity, if we see that fly ash combines with the free line and it make a calcium silicate hydrate. So which makes it as a durable binder. So this calcium silicate hydrate is a durable binder, where your free line, which is actually a calcium hydroxide, this is a non-durable binder. So it must react with the fly ash, which is our supplementary cementitious material, and it will make itself into a durable binder. So same as case of our silica fume. Again, finer fly ash has higher pozzolanic activity. So its fineness is there about, if you see, about 1700 to 5900 centimeters squares per gram. And ASTM C6718. Remember, this standard is very important. This is the standard which characterizes the fly ash. So there are three things it states actually. One thing about the chemical, there your Ca content should be there. Second one is fineness. It will tell you that this much should be the fineness of the particles over there. And it says that your 75 micron seeds, that maximum 34% should be retained on this. Then pozzolanic activity of there. So what is pozzolanic activity? If we prepare a cement mixture and we find out 28-day strength, this is called as pozzolanic activity, and we find out that your cement is giving you a strength of about 100 megapascal. Clear? So what happens if you add, let's say 20%, 15%? So once you replace the fly ash, your cement should give, that mixture with the replacement should give at least 75% of equivalent strength. It means if that mixture with fly ash is giving you about 75 megapascal, you can say that your fly ash is pozzolanic. Are we clear or not?
Yes, sir.
Beta, it means, let's say you have 100% cement and you have make a concrete, it is giving you 100 megapascal strength. And next concrete you made with the 75% cement and 25% fly ash. So if you prepare this cement concrete and you get out your strength has 80 megapascal, so it means your fly ash is pozzolanic in nature. This is called as pozzolanic activity. If it is less than 75%, its pozzolanic activity is less than 75%, that material we cannot use as a supplementary cementitious material. This is called as strength activity index as well. से हम strength activity index भी कहते हैं. Now composition of fly ash. दो types हैं जी, class F और class C. There are two types of fly ash. Class F fly ash की अगर आप बात करें तो 3 oxides, silicon dioxide, aluminium oxide और iron oxide. If their total sum is greater than 70%, this is your class F fly ash. If their total sum is greater than 50%, this is called as class C fly ash. So this is the maximum you can say difference we see by these 3 compounds in it. So rest you can also ignore, not a big deal. Then if you see effect on workability. So if your particles are regular, you will have improved workability. So in case of our fly ash, particles are spherical. So as these particles are spherical, our workability is improved. So remember, fly ash don't give you the early strength. It gives you the later age strength. Clear? Your fly ash is actually will give you the later age strength, not at the early age. Fly ash get activated in the later ages, 56 days, 90 days, it will give you the later age strength. So as much you added the fly ash, your bleeding water is reduced. Why? Because it uses actually, it enhances the bleeding water capacity of the system. Then your pumping is capacity is actually, pressure can be reduced. So pumping ability improved actually. Effect on fly ash, actually, if you see at early ages, fly ash strength is lesser and ordinary plain concrete strength is higher. But after 90 days, fly ash concrete have more strength, the normal concrete has lesser strength. This is the normally, as I told you, ash gain strength at the later ages, not at 28 days. If you want to make a concrete with fly ash, you need to monitor it at about 3 months actually. Are we clear?
Yes, sir.
But please do remember that fly ash is not giving you an early age strength. Fly ash will give you the later age strength. ये बहुत इंपॉर्टेंट है. इससे पहले दो चीजें जो हमने पढ़ी हैं जो बहुत इंपॉर्टेंट है, वन इज फिजिकल इफेक्ट, अनदर वन इज केमिकल इफेक्ट. So you need to remember it. So permeability rate is also reduced. So you see about, so it is being reduced. This is the reduced permeability as you increase the fly ash content. Why it is increasing? Why your permeability is being reduced? Because the particle size is lesser, because your unstable CH is being utilized by the fly ash. ये दो चीजें हैं अगर आपसे कोई पूछे. Again, chloride diffusion is also increased, improved with the fly ash. So all the characteristics which are related to the durability, they are increased. Now, how much percentage of fly ash may be used actually? There is ACI report, I don't remember the exact name, I think it's 228, ACI 228 or 232. One of them is there. It states that you can go for the cement replacement between 15 to 25%. They can say that you can go up to 15% with class F fly ash. Are we done with the fly ash, beta? Everybody is clear with the fly
Yes,
ash?
sir.
In most of the cases, while we are discussing in Pakistan, we are normally saying coal ash as a fly ash. हमारे पास यहाँ पे जो सबसे ज्यादा प्रॉब्लम आता है अपनी लोकल इंडस्ट्री में, तो हम अपनी कोल ऐश किसे कहते हैं? कैन एनीबॉडी टेल नाउ?
सर जब कोल को बर्न किया जाता है तो जो लेफ्ट ओवर होता है वो कोल ऐश होगी.
जो बर्न होने के बाद जमीन पे बचता है उसका ऐश, उसे कोल ऐश कहते हैं. और जो हवा के साथ उड़ के कलेक्ट होता है उसे फ्लाई ऐश कहा जाता है. ठीक है जी. सो हमारी लोकल इंडस्ट्री में जो सबसे ज्यादा प्रॉब्लम है कि हमारे पास रियल फ्लाई ऐश आता ही नहीं है. हम अपने कोल ऐश को ही फ्लाई ऐश जूम करके यूज कर रहे होते हैं और फिर हमारे पास लैब में रिजल्ट्स आते नहीं है और स्टूडेंट्स उन रिजल्ट्स की बेस पे मुख्तलिफ थ्योरीज डेवलप कर रहे होते हैं. Whenever you go for the research, you don't find the results, you find out something different, and students prepare some different stories about that. Clear? So what is the best way? The best way to start with the fly ash, actually you need to first of all characterize it. Get its SCM done, get its chemical composition done, get its particle analysis done, so that you can very strongly say that this is fly ash or not, and then you use it. मैं इसकी आपको example देता हूँ. I was doing research in my PhD back in 2012 or 2014. So I was preparing a mixture about 8 months to develop one concrete replica. कि मैंने एक concrete का replica बनाना था, वो मेरे से बन नहीं रहा. Although I was using the same material from the imported from Europe, it was not being made. I was getting failure every month. I prepare and I get failed. Later on, once I found that the fly ash I was using, there was not original fly ash actually. वो सही fly ash ही नहीं था, तो वो result मुझे क्या देता जी? So ये problem रहती है मटेरियल्स में कि हमारे पास यहाँ पे ये ट्रेंड है कि जो मटेरियल आया उसे वैसे यूज कर देंगे, कोई इशू नहीं है. कंपनी ने हमें कह दिया कि ये फ्लाई ऐश है, बट ऐसा ट्रू नहीं है. यू नीड टू फर्स्ट कैरेक्टराइज इट. As long as you don't characterize it, you cannot say that it is fly ash or it is silica fume. Are we clear? Ji?
Yes, sir.
Now we go for the slag. Talking about the slag, slag is the byproduct of metallurgical industry, जिसे आप आयरन इंडस्ट्री भी कहते हैं, जिसे आप आयरन ओर भी कहते हैं, उसका लेफ्ट ओवर है. सो इसे हम ब्लास्ट फर्नेस स्लैग भी कहते हैं. इसका दूसरा नाम GGBSCB है जी आपके पास, ग्राउंड ग्रेनुलेटेड ब्लास्ट फर्नेस स्लैग. वो यहाँ पे नहीं लिखा हुआ. The other name we name it as, actually that is called as GGBS. That is called as ground granulated blast furnace slag. Are we clear, ji?
Yes, sir.
So what we do in this case, this is the leftover of iron industry. What happens? This iron dust is actually there, metallurgical industry mein. So this iron dust is being further grinded actually, and after grinding, we use it actually for the as a binding material. So this can be activated chemically by using the low strength with the OPC. The best thing about this slag is actually it is a low heat of hydration cement. So whenever we need low heat of hydration, we use slag. In most of the dam sites, people use this slag as a binding material. They use it as a supplementary cementitious material. So this ground granulated blast furnace slag is there. Normally, fine is there. We get it about 4.75 millimeter in diameter to dense. Then we grind it actually to the fineness, cement fineness. And ASTM C989 is the standard which discuss it. We have 3 grades: grade 80, grade 100, and grade 120. Grade 120 is very high activity index, but it is finer. As you increase the grade, the fineness more. As you reduce the grade, the fineness is lower. So this is the major difference between these 3 grades. So this 80, 100, and 120 means the fineness is different. This is its SCM. You find it is more like a rock-like structure. Aggregates, very irregular type structure is there. Clear? So with respect to the workability, if you see, you increase this amount, you can have better workability actually. This better workability actually comes out by its low heat of hydration, because it lower the heat of hydration and setting time, so you can have improved workability over there, or better temperature effect as well. This is the best thing about the slag. So once you are recommending somewhere mass concrete, heavy concrete, where you can see a lot of volume of concrete is there, so you can also recommend that the slag should be there. So as I told you that its early age it is slower, but at later ages it is higher. Its strength development is higher at the early ages, slower at the early ages, but its strength development is faster at the later ages. So if you see after 1 year, so you will see that slag has got significantly in strength as compared to the normal Portland. So it can give you about 20% higher tensile strength. So due to its hydrated structure, it has better hydrated structure than the normal concrete. It means if we see that its rate of gain of strength is very low, it slowly gain the strength, it slowly get the strength, and on the basis of same rate of gain of strength, it has the higher modulus of elasticity. This higher model, can anybody tell what is the modulus of elasticity? Guys, can you tell me what is modulus of elasticity?
So when the material comes to its original,
जी जी Can anybody tell what is modulus of elasticity in concrete? बता सकते हैं जी कोई कि मॉडुलस ऑफ इलास्टिसिटी कहते किसे हैं?
so when the material comes to its original position after removing load, like complete, there is no formation of cracks in this region when it is elastic, when it is in elastic range.
The term you are telling, that is elasticity or non-elasticity. I'm talking about modulus of elasticity, what it is.
Sir, stress by strain ratio.
Division of stress and strain up to what state?
Up to elastic limit.
Within elastic limit. Okay. So what is the elastic limit of concrete? Can anybody tell?
So 0.003 mm स्ट्रेन तक जो
तो ये तो उसकी अल्टीमेट स्ट्रेन है जहाँ पे कंक्रीट फेल हो जाता है. मैं तो इलास्टिक स्ट्रेन की बात कर रहा हूँ.
Sir, slope of stress strain curve up to 40% of stress.
You can say this is one way of doing it actually. कितने मेथड्स हैं जिससे मॉडुलस ऑफ इलास्टिसिटी निकल आता है कंक्रीट का?
सर ACI का एक फार्मूला है और स्ट्रेस स्ट्रेन कर्व से निकाल सकते हैं.
How many methods are there to find out the modulus of elasticity for concrete? Can anybody tell? कितने मेथड हैं जिनसे मॉडुलस ऑफ इलास्टिसिटी फाइंड किया जा सकता है कंक्रीट का?
सर एक टेंजेंट मेथड है.
बिल्कुल सही कहा जी. और
एक
टेंजेंट मेथड है जी, सीकेंड मेथड है, इनिशियल टेंजेंट मेथड है और कॉर्ड मेथड है जिसे ASTM मेथड भी कहा जाता है.
बस एक ही याद था.
ये टेंजेंट मेथड बेसिकली नॉर्मली स्टील में भी यूज होता है, but the method which is used to find out the modulus of elasticity of concrete, that is chord method, जिसे ASTM का मेथड भी कहते हैं. ये याद रखें जी. That is the methodology where we have a stress strain curve and we go up to 45% of ultimate or 40% of ultimate strength and initial 50 millionth strain. इसकी स्लोप लेते हैं तो वो हमारे पास मॉडुलस ऑफ इलास्टिसिटी आता है. Anyhow, this is a side discussion. We don't detail. I think you are well learned in it. आप लोग काफी अच्छे trained है इसमें already. Just revision was. So coming back to this slag strength development rate is lesser, even far slower than the fly ash actually. So if you see at early ages it has very low strength, but later on at the age of 128 days or 300 days it is having a far higher strength than the ordinary Portland cement. So this is the characteristics you need to remember for the supplementary cementitious materials. Then comes natural pozzolans. Natural pozzolan किसे कहते हैं? मैंने भी आपको थोड़ी देर पहले बताया था बेटा. What is natural pozzolan? Hello, are you there?
Lime.
नेचुरल पोजोलान किसे कहते हैं?
सर जो सीमेंटिशियस वैल्यूज ना रखे हैं कैल्शियम हाइड्रोक्साइड
बेटा
के
नेचुरल
साथ,
पोजोलान इज एक्चुअली एनी बेटा नेचुरल पोजोलान इज एक्चुअली अ पोजोलान विच इज नेचुरली अवेलेबल. ठीक है, जो नेचुरली अवेलेबल है. मसलन आप देखें कि जो भी रीजन वोल्केनिक इन नेचर, the region which is volcanic in nature, there this pozzolan will be available. Just like its name is actually being originated by Pozzuoli near Naples, इटली में है जी, वहां से ये ओरिजिनेट होता है. और जहां पे भी दुनिया में पोजोलानिक एक्टिविटी हो रही है, वोल्केनिक रप्ट हो रहा है, इसका लेफ्ट ओवर, जब ये वोल्केनिक ऐश निकल जाता है और इसका जो लेफ्ट ओवर बचता है वोल्केनिक eruption के बाद, उसको हम जो ऐश बचती है उसको कहते हैं नेचुरल पोजोलान. इसको ग्राइंड कर लिया जाए तो ये बहुत अच्छा बाइंडिंग मटेरियल बनता है. आर वी क्लियर स्टूडेंट्स? आर वी क्लियर?
Yes, sir.
Yes, sir.
So this is the ash which is generated after the volcanic activity. आपके पास वोल्केनो आया, उसके बाद जी वो रप्ट हुआ, वो निकल गया, और ये बड़ी दुनिया में अभी पड़े हुए होंगे. अभी भी हमने अभी दिया मीर बादशाह डैम पे मैं था, so there was a material engineer who was working on it. So they are trying, there is a rock on this region जो left over of a volcanic ash है. Which means कि कहीं आज से हजारों साल पहले वहां पे कोई volcanic activity हुई होगी, तो वहां से वो ऐश निकली है volcanic. And they are trying कि इसको हम ग्राइंड करके यूज करें एज ए बाइंडिंग मटेरियल. इन दिया मीर बादशाह डैम की मैं बात कर रहा हूं. Then comes rice husk ash. Rice husk ash से क्या समझ आती है बेटा?
सर ये जो चावलों का भूरा वगैरह होता है.
बिल्कुल, इसको जलाएं और इसके जलाने के बाद जो ऐश बच जाए आपके पास, ये हाईली जल्दी से रिएक्टिव नहीं, इसी फाइनली ग्राउंड करते हैं या कंट्रोल कंबशन कर ले, देन मे बी इट गोज इनटू द rice husk ash. Clear? So once you do it, you can take it to the as a natural or pozzolanic activity like this. In my case, once I did it, actually I couldn't find any rice husk ash which can give higher strength upon replacement. लेकिन यहाँ पे ये दिखा रहा है आपको कि 7 से 12% तक ये आपके पास इंक्रीज स्ट्रेंथ आ रही है. जो मैंने अभी रिपोर्ट किया था उसमें मैंने कहा कि ये जो राइस हस्क ऐश है ये नहीं सही थी. तो मैं आपको दोनों पिक्चर्स बता रहा हूँ बेटा, मर्जी आप लोगों की है, हाउ यू टेक इट एक्चुअली. नाउ दिस लास्ट टेबल इज देयर which gives you the comparison between different kinds of supplementary cementitious materials and their chemical composition. If you see, this complete table is there, through which one table you can find out how much silica content is there. If you see the silica fume, 90% silica content is there, whereas in all other cases it is more or less about 35 to 50%. This is the last slide for us actually for the supplementary cementitious materials. Do you have any questions, students?
No,
CR, are you there?
yes, sir.
बेटा प्लीज इनकी अटेंडेंस मार्क करें और मेरे से शेयर कीजिएगा प्लीज.
Okay, sir. Kindly सब अपने जो registration number था
Everybody, please share your registration number with the CR or within this chat.
chat box
There are
में
total,
share
I
करते हैं
think,
अपना registration number सब.
चैट बॉक्स में शेयर कर दें. so that he can mark your attendance and share it with me. So here we have total 29 students, I think.
Yes, sir. 30 hours. Okay, sir.
भाई मैं भी तो है ना काका,
जी सर.
मेरी भी attendance है.
Okay, sir.
Okay, if you have given your registration number, you can leave the room after giving your registration number. All of you, please, once you give your registration number, you can leave the room. Thank you very much, beta. I'm here until everybody leaves the room.